Hello everyone and welcome to your partner in education, Agile Rank Mate. Today, in this episode of Keam Crash Course, we're going to be looking at some sample questions from the subject that is mathematics. So we'll be looking at a couple of math questions and how to solve them effectively. So, today's questions are based on differentiation mostly, so let's start off with our first question. If y is cos x raised to 2x, then dy by dx is equal to 2 cos x raised to 2x times sine x minus x tan x, and then a couple of other options. So you got 5 options here. We need to find out which of these options is the right one. Now, if you look at what's given to us, is y equals cos x raised to 2x. Now, your first instance, the first idea would be to do differentiation as is. However, since we've got an exponent, let's try to alleviate that by using the log function, the logarithm function. So if y equals cos x raised to 2x, then by applying the log function, you'll get log of y as equal to log of cos x raised to 2x. Now, log of a raised to b is the same thing as b times log a. So this is why we use log in the first place, so that the function now becomes 2x times log of cos x. Now from here, of course, you can differentiate with respect to x. So log d by dx of log y on the left hand side is what we get on the left hand side. D by dx of log y is the left hand side. The right hand side would be d by dx of 2x times log of cos x. So first things first, you can remove the 2 from here and put it outside, because 2 is a constant. So the coefficients are taken outside as is. Now, if you look at the bracket on the right hand side, you can see that it's x times of log x that we have to differentiate. So here we would have to make use of the product rule, which says if you have to differentiate a product of 2 functions, then the differentiation would go first function times the derivative of second function plus second function times the derivative of the first function. So let's apply that as we go. On the left hand side, it's d by dx of log y. Now, since d by dx of log x is 1 by x, we can use the same theory and write 1 by y times dy by dx. So say if this was log x, then we could have just written 1 by x dx and be done with it. But since this is a function of y, we have to write 1 by y times dy by dx. So that's the left hand side. Let's look at the right hand side. 2 goes out since it's a coefficient and a constant, and now we apply the product rule. So it'll be x times d by dx of log of cos x plus the second function here is log of cos x times d by dx of x. So the left hand side is still going to stay the same. Let's go to the right hand side and work on it. So the right hand side would now be 2 times x of, since it's a logarithm of cos x, we would have to write the function as 1 by cos x times d by dx of cos x. So whatever is in the bracket has to be differentiated again. Now, the right hand side, since d by dx of x is 1, we would only have to write log of cos x. This here is equal to 1, which is constant. So 1 times anything remains whatever that is. So continuing the differentiation, so 1 by y times dy by dx on the left hand side would give us on the right hand side 2 times x into 1 over cos x, and then the differential of cos x would be negative of sine x, plus the second term is log of cos x, and that stays as is. Now, what we can do is, what we really need in the question is the value of dy by dx. However, our left-hand side is 1 by y times dy by dx. So what we do is y goes to the right-hand side. So that's what we're doing. So y goes to the right-hand side, which means our left-hand side remains dy by dx, which is our final left-hand side. Now, y goes to the numerator, so what we get is 2y outside the bracket, and then inside we will rearrange whatever we have like this. So log cos x is positive, so it comes first. Then we add the minus sign, and then we have x times, we have sine x in the numerator and cos x in the denominator. Sine divided by cos gives us tan, the tangent function. So the second part of that bracket would be x tan x. So this is what we get. Now, we can't just leave y on the other side, on the right hand side. We would need to expand it in terms of x. Luckily, we know what y is, so all we have to do is to substitute y. So what we get is 2 cos x raised to 2x times, in the square bracket you have log of cos x minus x times tangent of x. So this is the final value of dy by dx for this particular equation. So dy by dx in the end is equal to 2 cos x raised to 2x times log of cos x minus x of tan x. Now this particular answer that we get, if you look at our options, turns out to be equal to option E. So option E turns out to be the right answer. The others aren't exactly what we get, because what we had to do here was convert the y function into log y and convert the right hand side accordingly, and then differentiate. We had to use the product rule. We had to use a lot of differentiation standards with respect to trigonometric functions and other things. So therefore option E, 2 cos x raised to 2x log of cos x minus x of tan x, turns out to be the right answer. Now let's look at another question. If x cubed plus 2xy plus 1 by 3y cubed is equal to 11 by 3, we need to find out dy by dx at a specific point that is also given to us, 2 comma minus 1. The value would be minus 2, 2, 5, minus 5, or minus 10. Those are the options that are given to us. So again, we're using coordinate points here. So the ordinate is, the abscissa is x, is the x value, so that's 2. The ordinate is the y value, which is minus 1 here. So in order to start off with this question, we would need to differentiate it with respect to x. And once we get the differentiated equation, we can just add the values for x and y. So the equation that we have here is x cubed plus 2xy plus 1 by 3y cubed. Now this would be equal to 11 by 3. We will need to differentiate this with respect to x. So when you differentiate it with respect to x, on the left-hand side, you get d by dx of x cubed plus d by dx of 2xy. Now this means we would have two functions to work on. Again, 2 is a constant, so we can always take it out. So 2 times of d by dx into xy. So d by dx of xy is what we have, the second derivative. And for that, we would have to use the product rule. And finally, in the third derivative, you can take 1 by 3 out because it's a constant, d by dx of y cubed. And then here we've got d by dx of 11 by 3. Now 11 by 3 is a constant. It's not a coefficient to any variable. So the right-hand side would finally turn out to be 0. So when we start solving this equation, d by dx of x cubed. So here we're going to use the standard differentiation formula, d by dx of x raised to n. This is equal to n of x raised to n minus 1 times dx. So n raised to x minus 1 is what we need to convert x cubed into. So n here is the exponent, which is 3. So what we get for the first differential is 3x raised to 3 minus 1, that's 2. For the second one, we'll have to use the product rule. So 2 times, when we do the product rule, you get x times dy by dx plus y times dx by dx, which is basically 1. And then you got 1 by 3 times. We're going to use the same idea that we used for the first differential for the third one as well. So that will be 3y squared. However, since this is a different variable, we'll have to do a dy by dx here as well. And then the right-hand side, as we said, would be 0. Continuing to work on the left-hand side, what we get is 3x squared plus, what we're gonna do is we're gonna distribute 2 across the two sides. So that will be 2x times dy by dx plus 2y plus y squared times dy by dx, which is equal to 0. Now, since we need to find the value of dy by dx, what we're gonna do is we're gonna take dy by dx as a common term for 2 of these particular terms. So the left-hand side now becomes 3x squared plus y squared plus dy by dx times y squared plus 2x, which is equal to 0. Now we're going to take the two terms that did not have dy by dx to the left-hand side, to the right-hand side. So dy by dx multiplied y squared plus 2x is on the left-hand side. The right-hand side would be minus 3x squared minus y squared. Plus 2y. The second term that doesn't have dy by dx is 2y, so we would have to correct that. So minus 2y. In order to keep dy by dx by itself on the left-hand side, the second y squared plus 2x is brought to the right-hand side, so it goes under the numerator, so it's a denominator here. So what we get is minus 3x squared minus 2y divided by 2x plus y squared. So this is the differentiation. This is the value of dy by dx at any point along the function which we have. So what we're going to do is apply the coordinates. So when you apply the coordinates, what we get on the left-hand side is dy by dx at the points 2, minus 1, which means we're going to have to add 2 in every place of x and minus 1 in every place of y. So what we get is minus 3 times 2 squared minus of 2 times minus 1 over 2 times 2 plus minus 1 the whole squared. So 2 squared is 4. 4 times minus 3 is minus 12. Minus 2 of minus 1 is plus 2. And then in the denominator, it'll be 4 plus the square of negative 1 is still 1. Negative times negative gives you a positive. So what we get is minus 10 over 5 as the value of dy by dx at 2 comma minus 1. This fraction can be brought down to the integer that is minus 2. So minus 2 is officially the value of dy by dx at 2 comma minus 1 for the function x cubed plus 2xy plus 1 by 3y cubed equals 11 by 3. So minus 2 is our answer. If we look at our options, you can see that option A is the correct option in this case. Minus 2 turns out to be the right answer. So what we did here is we differentiated the equation that we've got using multiple rules for differentiation, such as the product rule and also the general rule for differentiation, d by dx of x raised to n. And once we got that, we separated the term dy by dx to one side and everything else on the other side after simplifying. And then after that, it was simply a matter of substituting x with 2 and y with minus 1 to get our answer, which is option A, minus 2. So that concludes this episode of Keam Crash Course. We hope you found this episode interesting. For more of our useful and interesting content, don't forget to subscribe to Agile Rank Mate, your partner in education. If you want to get the latest updates from our channel, then please don't forget to hit the bell icon present below the video. So until the next webisode, take care, stay alert, bye-bye for now.